Hi, and welcome to TEMEKO. In this video, we will take a look at the definition of the moment of a force and also how to define any moment about a certain point or axis by using scalar and vector formulation. Let's get started. So what do we mean by the moment of a force? Well, the moment of a force is the measure of a body's tendency to be rotated about a certain point or axis when a force is being applied on it at a certain lever distance. Think about how a wrench works. When you're applying a force on it, it will tighten the bolt or the nut. What causes this? It's the moment of a force. The thing about the moment of a force is that the greater the force or bigger the lever arm is, the greater the moment you are creating. You may have noticed that if you use a wrench that has a bigger handle, then you won't need to use that much force to tighten the bolt or a nut. On the other hand, if you use a smaller handle, then you need a lot more force in the same task. This relation can be written by using the scalar formulation as follows. MO equals F times D, where D is the moment arm or perpendicular distance from the axis at a certain point O, and F is the applied force. The unit of the moment magnitude is derived from the units of the force and the distance, which is Newton meters. As some of you may have already figured out, the moment of a force is a vector quantity because instead of having only a specified magnitude, it also has a direction. The direction of the moment can be determined by using the right-hand rule. The right-hand rule tells us if we put our curled right-hand fingers in such a way that they would follow the direction of the force, which rotates about the point O, then our right-hand thumb will be pointing to the direction of the moment vector. As you can see, the moment vector is upward and perpendicular to the plane, which is formed by the force vector and the distance. In the planar case, the direction of the moment can be determined in the same way, but our right-hand thumb would be pointing out of the page. The most important thing that you should remember about the direction of the moment is that the magnitude of the moment will be positive if its direction is counterclockwise and negative if the moment is rotating clockwise. Let's move on to how we can define the moment by using a vector formulation. Why do we need it? As earlier videos have shown, vector formulation comes in handy when we have more complex problems than just problems which are in 2 dimensions. In vector formulation, the moment of a force about a certain point O is described as a cross product as follows. MO equals R cross F, where R is a position vector drawn from the point O to any point lying on the line of action of force vector F. The magnitude of this moment vector can be written as follows. MO equals R times F times sine theta equals to F times R sine theta. This leads to the same equation that was in the scalar formulation case. The direction of the moment vector was already established when we discussed about scalar formulation, and the same rule also applies for the moment direction in vector formulation. One thing that we have not discussed yet is how to use Cartesian vector formulation to solve the moment vector. If you remember from the earlier video, we established how to solve the cross product between 2 vectors. We normally use Cartesian vector formulation and the determinant solving method to solve this kind of problem. As a reminder, we had the following determinant, which leads to the following solution. Some of you may have already figured out how the procedure will go when we are applying this to solve the moment vector. Like in the general case, we have 2 vectors, which in this case are the position and the force vector. Now the determinant for these vectors can be written as R cross F equals determinant of I, j, k, rx, ry, rz, fx, fy, fz, which leads to the following solution. MO equals Ry times Fz minus Rz times Fy times I minus Rx times Fz minus Rz times Fx times J plus Rx times Fy minus Ry times Fx times K. If you look at the solution more deeply, then you may find the physical meaning from this solution. In general, each component of the moment can be determined from the moments of the force components about certain axes. For example, if we want to find the moment about y-axis, then we would look at the j component of MO. You may notice that the force component Fc and Fx are contributing their own moment components Rx times Fc and minus Rz times Fx, of which the magnitude of the sign is determined by the right-hand rule. Notice that the force component Fy is not creating a moment about the y-axis, since the component is parallel to the y-axis. Normally, if we would solve the moment of a force about a certain axis A' by using vector analysis, we would first solve the moment about a certain point O, which has already been established during this lecture. After this is done, we could determine the moment about the axis A' by using the dot product, which can be written as follows. MA equals UA dot MO, where MO is the moment about a certain point O and UA is the unit vector of the axis A'. So basically, we are solving the following determinant. MA equals UA dot R cross F equals determinant of UAX, UAY, UAZ, RX, RY, RZ, FX, FY, FZ. Hopefully after watching this video, you know what is meant by the moment of a force, and you know how to define the moment about a certain point or a certain axis by using scalar and vector formulations. You also have an idea how to determine the direction of the moment by using the right-hand rule. Thanks for watching and have a nice day.